A quick word from FusionAuth. FusionAuth is the customer authentication and authorization platform that makes developers' lives awesome. You'll get all the features your app needs, plus a customizable, scalable solution you can run on any computer, anywhere in the world. The next speakers are Greg, Brett, and Matt. Talk titled yubidisaster, building robust emergency admin access to AWS accounts. Give it up for them.
Hi, everyone. Thanks for coming. My name is Matt Jones. With me, I have Greg Kerr and Brett Caley. We're from Block's infrastructure security team, and today we're going to share about how we built robust emergency access to AWS. So we're going to go over kind of disaster recovery, kind of the motivation for this work and the success criteria that we had. Then we'll go into how we combined AWS Roles Anywhere, AWS PCAs, and YubiKeys to create yubidisaster. And then finally finish out with how we can expand these building blocks to work on any platform so that we can liberate ourselves from a single cloud provider. So, disaster recovery, right? So like in computer security, we have the CIA triad, confidentiality, integrity, and availability. So as we're trying to build in more confidentiality and integrity through things like just-in-time access to our cloud, we end up putting more and more infrastructure in front of that access. And then that gives more opportunity for a disaster or failure to take all of that out so we can't access our information anymore. So the problem with that is now you need some sort of backdoor, like a root password or something, and then that invalidates most of the security work we were trying to do to begin with. So that's kind of where we came up with what we call the dependency layer models, which we follow. So at the far left is layer 0, which is our cloud providers, right? AWS, GCP. And layer 1 is where we usually live, like we're building certificate authorities, our dual control enforcement and just-in-time access, networking infrastructure, and then our IDP. We put like Okta there as well. And then you have kind of moving into the application space, the platform infrastructure that actually starts Kubernetes and things like that, and then everything else that runs on top of it. But our big rule here is if everything goes down, you can't rely on layers above you for disaster recovery. And once we looked at that, we found out that we were actually violating this property, right? Like we needed our own infrastructure to recover our infrastructure, and then this slows down your mean time to recovery. So what we wanted to build was an access system that obviously met these dependency layer rules, right? Like we need to solve the problem. Then we needed it supported across a large amount of platforms. At Block, we have a variety of end user equipment. So we needed it to work across Windows, Linux, Macintosh, all that. And then finally, we needed something that met our security requirements. Block is a regulated company dealing with PCI and SOX and other regulatory environments. So we needed something that handled offboarding, policy and compliance, device attestation, something that was phishing resistant, and then also had attribution to who was doing what during an emergency. And then finally, we are a remote company, so we couldn't go to a safe because that would slow down our time to recovery. So Brett is going to talk about how we built yubidisaster to achieve these goals.
Yep, thank you, Matt. So we wanted to conceptualize yubidisaster into, I think, 3 distinct phases. And so this represents sort of like the timeline of a disaster. Our first stage is we'll have preparation, so that's essentially binding a user to their YubiKey and establishing usage of yubidisaster. The next step is to sort of imagine the emergency state. So we want to use these bound credentials to generate emergency credentials and then perform that disaster recovery. And then state where we want to ask like, okay, so what exactly has happened, who did what, and why? So to sort of talk more about the preparation state, we wanted to create a process by which users could enroll in the program. We'd create trust relationships, and then users would be able to perform exercises. And so what we wanted to build out as part of our required infrastructure are 2 certificate authorities, essentially the enrollment certificate authority and the just-in-time certificate authority. So the enrollment certificate authority will be longer lasting on the order of maybe like multiple months to a year. The just-in-time certificate authority will issue certificates sub 1 day. And then we'll also create these request inspector lambdas. These will essentially act as authorizers or areas where you can insert different actions such as multi-party approval. For our demonstration or our talk today, we're going to ignore that portion as it complicates the diagrams a little bit, but this is certainly an area where you can expand that. And so from a user's perspective, a user will essentially generate a certificate request from their YubiKey. They'll submit that request through an identity-aware proxy where our inspector Lambda will verify several security features such as the hardware attestation policies for touch and PIN requirements, as well as any sort of ACLs that you wish to sort of fit in that space. And then once all of that has been verified and validated, the certificate authority will issue a certificate to that user, which will then be stored in their YubiKey for use later. And so this is essentially that a diagram of that description, which we'll leave in for any review later. And so this brings us to the emergent event. So our users are prepared, they've been exercising, they've been doing their DRs. This process is essentially, okay, something catastrophic has happened and we can no longer access those L1 requirements. So when a user wants to recover from that disaster, they'll generate a second certificate request on their YubiKey. That user will then submit that via a authenticated session that was using the enrollment certificate. Then the inspector will verify that hardware attestation policy again, but now for the new CSR. So that new CSR will be checked against an ACL, so if you can't be accessing accounts that you don't have permissions to. And then once everything has been validated, they'll get a second certificate that's short-lived, again, that's sub 24 hours, which will then again be stored on the YubiKey in a second slot, and then that will be used to authenticate to your end role. And so this is that flow diagram. It's essentially the same steps, and it's just got that extra step where you log into your end account that has elevated privileges so you can do any sort of disaster recovery. And that leads us to our follow-up. So evidently this is a strong and very powerful access pattern. We want to make sure that you're not able to continue using this after a certain period of time, and we're able to track the activity that's happened so that we can build a narrative about the disaster recovery process. And so what that looks like is that we have our certificate authorities hosted by AWS PCA. So we'll generate audit logs that tracks certificate issuance. CloudTrail logs will help us doing analysis by providing the certificate properties such as the SPIFFE URI and CN for those certificates. These are all bound to hardware tokens, so this match with PIN requirements creates a tight association between the issued certificate and the user who is doing these actions, so you can trace back anything that you see in a log. And create a narrative of what a specific user has done during the disaster. These short-lived certificates expire, and that will limit any post-disaster access. You don't have to rotate roots, passwords, or do any new access key creation. And then our request inspector allows for revocation of access based on needs, such as if a user has been offboarded or any other sort of instance where a user would no longer need access to this platform. And that leads us to our building blocks, which Greg will present.
Thank you, Brett. Hi, everyone. I'm Greg. I'm also a software engineer on the team, and I'm here to talk about the building blocks, pun intended, to build this. As a reminder, block is, of course, a mix of Square, Cash App, and many others. But that being said, because we run most of our services in AWS, we've talked about a lot of AWS-specific technologies so far, but we actually submitted this talk as part of the Declare Your Independence track, because we believe that if you peel back the vendor-specific labels, these are just very common and well-known technologies that you could source from any vendor and build this design. So let's talk about what these generic things are you need. The first thing you need is a secure enclave. We used YubiKeys because we like them. They're cross-platform, they have good attestation, but there's no need to restrict yourself to that. For example, if your company is purely Mac OS based, you could have used the macOS Secure Enclave with fingerprint authentication as your proof of user presence. If you're Windows-based, I know Windows has TPMs, and I'm sure there are Enclave APIs to leverage that. What matters is the properties that that Enclave provides you. You want hardware-bound keys. It's really important because we all know from experience that if users can extract keys, they will. They don't mean to do harm, but it turns out it's easier if there's an emergency at 3 a.m. if you have that secret laptop at home that can get to prod. So don't enable that use case to happen. And that brings us to the next thing that you want, which is attestation. Please don't rely on paperwork, user promises, or manual verification to know that these secrets are actually hardware bound in the specific enclave that you think. So for example, with YubiKeys, we can get an entire certificate attestation chain that verifies to the manufacturer CA, and we can see that that attests to the same private key that's in the CSR, and thus we've constructed a trust chain. And then the last property is, of course, optional. We wanted something cross-platform. Like I said, you actually may not need that. For those of you who are interested in using YubiKeys or any smart card that presents the personal information verification interface, our great colleagues at Cash App have written a really useful tool that we use for some of our work, and it is open source on GitHub, and I put a link there for your future reference. And of course, we are in the future considering what else we can open source to make this more available. The next building block you need is a certificate authority. You'll notice I say manage certificate authority. That's because a certificate authority is so much more than running OpenSSL commands to verify CSRs and issue certificates. You need secure key storage with HSMs. You need to handle revocation, audit reports, intermediates, etc. And take it from me, unless your company is in the business of running CAs and you can have that division help you, you really don't want to moonlight as a CA operator. We used AWS Private Certificate Authority. We're very happy with it, but I know for a fact that Google Cloud also has a managed certificate authority, and I'm hopeful that in the future more cloud vendors will offer managed certificate authorities because they've been so powerful and useful for us. The things you need from your managed CA, the first is pretty obvious. It needs to issue standard X509 certs, and it needs to let you export the root certificate so that any code in any vendor can trust the CA. I couldn't imagine a CA that would do otherwise, but who knows? And then the thing that really helped us is be able to run custom service code in front of the CA. Again, you don't want people manually making API calls direct to the CA. By using service code, you can automatically check that attestation chain, and you can also check an access control list to make sure that only the proper people with proper attested CSRs are getting certificates. And that makes this a fully self-automated enrollment process. And it's been super easy to use, and with those audit logs and revocation, we have great confidence in what we've deployed. And then the last thing you need is a secure token service. I mentioned that we used AWS Roles Anywhere, which is what lets you configure certificates from a certain trust anchor to be allowed to assume a certain role. But what is that? It's just a secure token service, right? It's saying, hey, if you have some external identity that I know about and I'm configured to trust, then I will issue you an internal identity. So again, the key things you need from that are make sure it leverages standard PKI. If your STS only knows about your cloud provider credentials, then you're still locked in. The whole point of it, again, is this identity trust relationship. So make sure that you can set it up so that someone possessing a certificate from a specific certificate authority can access a certain role. That's the gist of this. And then the optional thing that's really helpful for us has been ACLs. For example, with our STS, AWS Roles Anywhere, we can have SPIFFE-based ACLs. So that service code that I mentioned, it can use our identity provider to know the username, and it uses the attestation code to know the YubiKey serial number. and it embeds it as a spiffy ID into the certificate. And then we actually have ACLs that we wrote in Terraform. So not anyone with a certificate can assume any role. You actually can restrict who can get to what service, and this is generally a good security practice, and it's really going to make your life easier if you're in an audit and compliance environment like many companies. So that brings us to the end of this talk. As you can see, we believe we met our success criteria. It's all layer 0, YubiKeys, AWS PCA, AWS Lambda, AWS Roles Anywhere. None of that is part of our Kubernetes infrastructure or anything. It's directly on AWS, supported across all platforms for us. I've tested it on a Chromebook myself. It meets the security requirements. We have offboarding, we have policy, we have attestation, we have audit logs, and there are no safe. Users use the same YubiKeys that they put into their laptops. And the one thing I left out on that note is part of the attestation for YubiKeys is you can attest that the user has entered a PIN and that they have touched the YubiKey. So that's why we're very confident without having a safe. And that is the end of the talk. Thank you very much for listening, and we've actually got 5 minutes for Q&A.
Start over here.
Presumably part of this to make it more useful, there's like scripts that run on the endpoints. Like how user friendly are those? And then sort of a related question is like when you actually go to test this, how long does it take in practice for somebody to actually use this and get the credentials successfully?
Yeah. Greg, you want to talk about the test we just did?
Sure. So Brett and I worked on a command line tool called yubidisaster. It takes one argument at this point, which is the account you want to access, and it also asks for your PIN. And then self-enrollment, like we said, self-enrollment, taking advantage of attestation, takes about 20 seconds. That's one command. And we have a sandbox account that you can sign into as if it's an emergency, but there's nothing sensitive there. And I run that test all the time. Most teams scheduled once a month. And again, it takes 20 seconds. It's one flag to the command line, and you just have to know your PIN.
But I think one of the things that we learned, especially in an emergency situation, right? Like the fewer command line arguments, the better. Like we had like an original version had like you had to put the account number, and like people got that wrong all the time, and not all the time, but like they got that wrong, and then it took longer to recover. So yeah, in disaster situations, less is more for command line arguments for sure.
And that's Brett who really polished up that tool.
So you're doing this at Block, which I can only assume is a pretty large scale. I'm curious how y'all could see this maybe scaling down, both from a technical perspective, but also financially, because like AWS private CA is not cheap, but I could definitely see smaller environments where this would be very useful. Now, do you have any comments on the finances of it or scaling it down?
Yeah, I mean, you know, we said that we wanted to use a managed CA so that we didn't have to use it. Like, there is nothing stopping you from, you know, using an open source CA for this to issue the certificates. And like AWS Roles Anywhere, like you just give it your trust bundle. So like that's one way. You know, we also use YubiKeys because we already had them deployed. So like, you know, we already bought them, let's use them. If you don't have that, I think like Greg said, you could, you know, you can bind it to kind of the trusted enclave on your platform. So I think that would be how I would scale it down.
Agreed.
Hey, so yeah, I work at Google, and we have a very similar thing for emergency access. So I think you did, you know, this is pretty much the exact same implementation. But I did have a question around two things. One thing, and you kind of touched on already, was like, do you force teams to practice this? And the other part of it was like, what's the like, do you still have a lot of dependencies? Like, are you still going through the identity proxy and have dependencies there, or do you have other maybe implicit dependencies, like maybe like dependencies on the documentation for this could be on something that's like down or through the identity proxy. So I was going to ask, like, what are the additional requirements here, or is it strictly zero zero dep and you're just able to directly SSH into an instance or something like that.
Right. Yeah, so you do need the identity-aware proxy for the enrollment stage. Like, that's when everything is up for, you don't need it doesn't actually go through the identity-aware proxy when you actually use it to get just-in-time credentials. And that's one of the reasons why we have the 2 phases to, like, cut that out. Yeah, for the documentation, that's a good point. At least on our teams, like, we put our documentation in GitHub and then, sync it to our laptops every so often. I don't know if you're back.
No, I was super proud of this one because I wrote a man page, which no one does anymore, but I actually wrote a man page, so it's all offline. And yeah, the one other thing I would say is teams do test this regularly, and part of the advised test procedures is to black hole the IDP in your DNS settings. And I've done some other stuff to make sure. I basically removed a device from our IDP enrollment to make sure that it works.
I was curious a little more about the creation myth and the origin of the story about how do you get funding and support to do this kind of thorough analysis. It would be in one kind of story if it had been prompted by a certain annual audit or a certain regulatory requirement or the arrival of a new leader who said this is something we need to do in the last place we did. But for those of us who don't maybe have this level of confidence that we know how to get out of an emergency, what are the kind of organization or cultural practices to get this kind of support?
So the thing that we had, so like we do postmortem reviews, and this came up as, as a result of an incident, like our mean time to recovery was slower because of this happened. And then that's what we used as justification for this. So we said, oh, hey, we could actually make this faster as a result of this postmortem. So that helped, like we had a very specific instance that allowed us to fund this work. Yeah, I would imagine you could pre-mortem. Like you could use a pre-mortem in this too, right? It's like, oh, hey, like what happens if our, root DNS goes down, right? Then what will break and how do we do it? You could also probably do it with a tabletop exercise where it's like, okay, what would we do in order to do this? Or to be honest, you could do it with a, some sort of disaster recovery exercise where, in a controlled manner, you bring down one of your core pieces of infrastructure and be able to bring it back up quickly. In case it doesn't go the way you think.
Either have incident or demonstrate the incident.
I think that's pretty much, that's the most like poignant way to kind of show that you need something like this.
So I think I'm trying to understand your threat model a bit better, and perhaps I just didn't pay enough attention. What's the motivation of shifting basically all the responsibility to AWS or your cloud service provider? You're basically now reliant on that your AWS account is not compromised, right?
Yes. Yeah. So the reason that we did this was for kind of the dependency layers, right? So like we use this to control access to our AWS accounts. So it's all, if those are owned, then all the stuff in them is already owned. Like you could imagine, like we use the IAM roles anywhere to get access to AWS. Anyone else who has like the PIV, anyone who could accept certificates as authentication, we could use that and we would have a different STS for that other platform. As for the root PCA, we are fairly confident with the fact that you can't export keys out of AWS, and that would allow us to recover. There's also the audit logs that gives us pretty strong ability to detect a compromise in that.
Okay, so basically, once the AWS account is compromised, you can't really recover from that? But
In the same way as any other,
yeah.
Yes, yeah.
Okay. Thank you.
Like, I'd say it's kind of orthogonal to yubidisaster, because yubidisaster is not how you normally sign in, it's in your emergencies. And I think what you're getting at is you absolutely need to have a detection and response team doing detailed investigations once this is used, though, because you've gone bypast your normal mechanisms, because they're all down, so that's fine, but yeah, you absolutely need a detection and response component to this, and you really need to, through paperwork and a variety of things, you really need to make sure that users don't start using this for normal sign-in. Like, we haven't had any issues, but if someone just started using this day to day, I would just pull their access because it's not appropriate for that.
Do one more question.
Could you actually detail a little more about why it's not appropriate for daily usage? Hearing y'all talk about this, it sounds very well considered, very user-friendly, very comprehensive in terms of your access control, authorization, and auditability things. Oftentimes having different regimes for disaster recovery means there's more to test, like y'all have also alluded to. So like, it sounds like a very compelling offering, and I'm sort of curious, like, what are the gaps that keep you from just saying, we're going to use this for all access all the time?
Yeah, the big reason is like, because you don't know what access you need in a disaster, like the roles that these go into tend to have a lot of privileges, and where generally we like to separate those privileges out so that you ask for a subset of your permissions. So like, this is why, and then the other one is like, for our detection and response teams, basically like anytime this gets used, it is something to investigate. And in fact, you would know about it because like it's a company event.
They get paged at 3 a.m.
They do get paged. Every time this is used, our detection and response team gets paged. So like, this is why like we want to separate these usages so that it's a very clear signal when this is used. Otherwise, if it was in daily use, there would be a lot of noise and like, oh, is this something, you know, that we need to investigate or not? But I think it's a good point, right? Like when you separate your disaster recovery from your normal action, it's very dangerous, which is why we have to drill the usage so often.
Thanks, everyone. Give one last round of applause for our speakers.